Hello, in this video we're going to talk a little bit about oxidation reduction and some of the different definitions for oxidation reduction reaction. I'm going to go through these and that you use whatever definition is best suited for your purposes at the time, be able to identify what an oxidation reduction is. Some of these will be very helpful when you get to taking organic chemistry, so file these notes away for them. So an oxidation and reduction, they always accompany one another. You can't have an oxidation reduction reaction without both taking place because there's a transfer of electrons from one species to another. And the question is, how do you go about identifying that transfer? Sometimes it's not always obvious. So the mnemonic we used was Leo the lion goes grr, or oil rig is another mnemonic. Leo, loss of electrons is oxidation. Grr, gain of electrons is reduction. Or oil, oxidation is loss. Rig, reduction is gain. So here are some definitions, and we're going to pair these together as we go along. The oxidation is the loss of electrons. Reduction is the gain of electrons. If you're losing electrons, you're increasing your oxidation number. It's becoming more positive. So it's an increase in oxidation number. If you're being reduced, you're gaining electrons. That means you're becoming less positive. It has to be a decrease in oxidation number. So when you're using oxidation numbers, that's easy to see. If you're not using oxidation numbers, sometimes you can look at the oxygen that's involved in a reaction. Oxygen isn't always in a reaction, so you can't always use this, but if it is, this will be a help. And that the gain of oxygen is an oxidation. Wonder where the word oxidation originated from. So if the oxidation is a gain of oxygen, reduction must be a loss of oxygen, if there's oxygen in the reaction. Likewise, a loss of hydrogen is an oxidation, if there's hydrogen in the reaction, whereas a gain of hydrogen will be a reduction. When looking at organic chemistry, if you look at the number of carbon-hydrogen bonds in a molecule, that decreases, it's an oxidation. Whereas if the number of carbon-hydrogen bonds in organic molecules increase, that's a reduction. If there are carbon-oxygen bonds in an organic molecule, an increase in the number of carbon-oxygen bonds is an oxidation. You might be going from a carbon-oxygen single bond to a carbon-oxygen double bond, for example. Whereas a decrease in the number of carbon-oxygen bonds is a reduction. An oxidation is always caused by an oxidizing agent, whereas a reduction is caused by a reducing agent. As we start off by speaking, oxidation is always accompanied by a reduction, and a reduction is always accompanied by an oxidation. So these rules give a way to define an oxidation reduction in multiple ways. You use whatever is convenient for you. So for example, let's consider this reaction, which shows this half reaction that shows an oxidation by the loss of electrons. Fe solid goes to Fe2 plus ion plus 2 electrons. We're losing electrons. Loss of electrons is oxidation. The iron is going from a 0 oxidation number to a +2 oxidation number. An increase in oxidation number is an oxidation. So either way, we'll let you look at that. If you look at copper, 2 plus, going to copper solid, it's gaining 2 electrons. Gain of electrons is reduction. Or you can look at it in terms of oxidation numbers. The charge on the copper 2 plus gives us an oxidation number of +2. Copper metal has an oxidation number of 0. A decrease in oxidation number is a reduction. So if we look at this in a chemical reaction without having looked at it in the half reaction form, we see that iron is going from 0 to +2. That's a gain of oxidation number, an increase in oxidation number, that's an oxidation. That means the other species has to be being reduced. The copper is going from +2 down to 0. So the species being oxidized is the iron. It's undergoing oxidation. The copper 2+ is the species that's being reduced. So what's the oxidizing agent? The oxidizing agent is causing the other thing to be oxidized. So what was oxidized? The iron. So the oxidizing agent has to be the copper 2+. That's oftentimes confusing to people, so don't let that happen to you. And whenever we're looking at oxidizing and reducing agents, they're always reactants. So if copper 2+ is the oxidizing agent, that means iron must be the reducing agent, the iron solid. Because the iron is causing the copper to be reduced from +2 down to 0. Let's look at this other equation, chemical equation. It says that 2 copper that are solid plus O2 gas, molecular oxygen, reacts to make 2 CuO that's a solid. So let's, instead of doing the 2 half reactions, which we could do, let's just look at the oxidation numbers of all the species that are in here. So the reactants are both elements, standalone elements. Copper solid has the oxidation number 0. The O2 molecular diatomic oxygen has the oxidation number 0. If we look at the copper oxide, oxygen almost always is -2. Copper here, in order to have everything add up to 0, has to have a +2 oxidation number. So copper is going from 0 to +2. That's an increase in oxidation number. That's an oxidation. Oxygen, you would think, would be a good oxidizing agent. If we jump down to question number 7, is what's causing the copper to be oxidized. And so the oxygen is going from O2 to -2. It's a decrease in oxidation number. That's a reduction. So oxygen is the oxidizing agent, and that means iron solid must be the reducing agent. So what's being oxidized is the copper solid, and what's being reduced is the O2 gas. Can be confusing. Try not to let it be confusing. Remember your rules. They'll let you figure out what's being oxidized and what's being reduced. And then the agent, oxidizing or reducing agent, is what's causing that oxidation or reduction to take place.